A journey that might sound like it's straight out of a sci-fi movie, but trust me, it's happening right now. Imagine it's the year 2200 and humanity has found a way to farm beyond the Earth. No, we're not just talking about growing a few plants in a space station's greenhouse, but full-fledged, thriving farms on the Moon, Mars, and beyond. Sounds wild, right? Now, you might be wondering, how did we get to this point? Well, let's rewind a bit. Not too long ago, we were just struggling with how to deal with food shortages, changing climates, and the limits of our resources here on Earth. Farmers were getting more creative, trying new methods to produce food more efficiently. And then came the big question, what if we could farm on other planets? The idea first seemed like a pipe dream, but fast forward to the 22nd century, and it's become a lifeline for humanity. Space farming, yep, it's a thing now. But before we dive into what this farming on Mars or the Moon actually looks like, let's take a step back and think about why it's so important. Food. It's one of the most basic needs of life, right? Without it, nothing else really matters. And as Earth's population grows and resources become scarcer, finding ways to produce food beyond our planet might just be the answer we've been looking for. So let's set the stage for the world we're talking about here. By 2200, farming is no longer limited to just fields, greenhouses, or even Earth's atmosphere. We're talking about entire ecosystems designed to support agriculture on other worlds. Places where the soil is nothing like what we're used to, the atmosphere is thin, and the sun barely makes it through. Yet, against all the odds, these farms are thriving. Crops are growing, people are eating, and humanity has figured out how to feed itself off-world. But how? How did we get from soil to spaceships? And how are these new farming techniques making it possible for us to survive in the harshest environments in the universe? Stick with me, because we're about to take you on a ride through time and space to understand how this all came to be. We'll explore the tech that makes it all possible. Things like hydroponics, vertical farming, and a whole lot of innovation that started right here on Earth. We'll meet the people who are living and working in space to grow our food. And we'll dive deep into what it's like to farm on Mars, where the atmosphere is only about 1% of Earth's and temperatures can plummet to minus 100 degrees Celsius at night. Spoiler alert, it's not easy. But before we get to the farming itself, let's take a look at how we reached this pivotal moment in human history. How did humanity evolve from tending to Earth's fields to cultivating crops on worlds we used to only dream about? What were the events that pushed us to go beyond Earth to solve the food crisis? Okay, let's rewind the clock a bit to a time when space exploration was in its early days. The idea of living on another planet was just that, an idea. The Moon was the first target. But as you can imagine, life there isn't as simple as planting a few seeds and hoping for the best. The Moon is a barren, airless rock, so why even try? Because when you're facing a food crisis on Earth, it's worth exploring every option you can think of, even if it means starting from scratch, literally. So what did we do? We started sending out missions not just for exploration but for something way more practical, to figure out if it was possible to grow anything in the Moon's dust, in Mars's freezing soil, or even on asteroids floating out in space. We needed to test if humanity could survive long-term in these far-off places, and to do that, we had to figure out one thing first: food. And that's where the journey began. Fast forward to the late 21st century, and the first experiments were underway. Scientists and astronauts worked together to test different methods of growing food in space. It was tough, because when you don't have Earth's natural resources, soil, water, air, everything becomes an obstacle. The question was, could we replicate Earth's conditions in space? Could we simulate what plants need to grow, sunlight, water, nutrients, and create a system that would work on the Moon or Mars? The answer, as you might expect, was not simple. They had to get creative, really creative. Early attempts were often failures. Plants just wouldn't grow the way they did on Earth. Without gravity, without proper sunlight, and in controlled environments, crops struggled to thrive. But the scientists weren't giving up, they were determined. And this is where things started to get interesting. They began to experiment with hydroponics, the practice of growing plants without soil, using nutrient-rich water. The early prototypes were small and experimental, but they had huge potential. What if you could grow food with only water and sunlight, no soil at all? And as they started getting results, even if they were small, it became clear that space farming was no longer just a crazy idea, it was a real possibility. But it wasn't just about getting plants to grow, it was about creating an entire ecosystem that could support life in space. That's what made space farming so revolutionary. It wasn't just about farming, it was about sustainability, how to make sure that these colonies on other planets could survive without constant support from Earth. Because let's face it, Earth wasn't going to be able to send supplies forever. They needed to be self-sufficient. And so, little by little, the pieces started to fall into place. New technologies were developed, vertical farms began to pop up in space stations, artificial lighting was used to simulate sunlight. And over time, we figured out ways to make space farming a reality. But that doesn't mean it was easy. It wasn't just about planting seeds and hoping they grew. It was about creating a balance, an environment where everything worked together: air, water, light, and the crops themselves. The future of humanity's survival off Earth depended on this balance. Now let's get ready to step into the year 2200 and see what this future really looks like. The first farms on the Moon, Mars, and beyond aren't just experiments anymore. They're thriving, essential parts of the interplanetary way of life. But how? How do these farms work? What do they look like? And how are people living and working on these farms every day? Let's take a look. Alright, now that we've set the stage, let's talk about how we got here. The journey from Earth to space farms. It wasn't as simple as just packing up and heading to the moon with a bunch of seeds. No, it took a whole lot of science, some trial and error, and a whole lot of guts. Let's rewind to the 21st century, where things were starting to get really serious. The planet was facing some pretty serious challenges. Climate change, population growth, and dwindling resources were just a few of the issues putting pressure on traditional farming. Crops were failing, and farmers were struggling to keep up. Meanwhile, on Earth's doorstep, the space age was heating up. Humanity was already thinking about going to Mars, exploring other planets, and maybe, just maybe, finding new places to live. But what good was exploring the stars if we couldn't feed ourselves once we got there? The answer to that question began to take shape in the late 20th and early 21st centuries. The first space farms were experimental, mostly small-scale projects on the International Space Station. Scientists had to get creative. How do you farm in a place where gravity doesn't pull things the way it does on Earth? Where the atmosphere is non-existent and sunlight is weak and unpredictable? The answer? Innovation. And that's where things started to get really interesting. It wasn't just about sending a few astronauts into space and hoping they could grow some lettuce. Scientists were asking some pretty big questions. Could we grow crops in a vacuum? Could we use water, sunlight, and a little creativity to create a system where plants could thrive in space? The first experiments were small, but they made history. They showed that, yes, plants could grow in space. They could survive. And while the experiments were far from perfect, they proved that space farming was worth pursuing. The first big breakthrough came in 2015 when NASA successfully grew a crop of red romaine lettuce in the veggie experiment aboard the ISS. This wasn't just a fun little side project, it was a major milestone. It proved that we could grow food in space, but of course lettuce is easy compared to the diversity of crops we rely on here on Earth. What about grains, or root vegetables, or fruit? Could we grow those too? NASA and other space agencies began working on more advanced technologies. Hydroponics, the method of growing plants in nutrient-rich water instead of soil, was one of the first solutions. But hydroponics alone wouldn't be enough. Researchers also started working with something called aeroponics, where plants are grown with their roots suspended in the air and misted with nutrients. It was all about using as little space and water as possible while getting the best results. By the 22nd century, things had evolved even further. The space farms we have today are a product of all those early experiments. Imagine an enormous greenhouse sitting on the surface of Mars, or inside a dome on the Moon. These are not just makeshift solutions, they're carefully designed ecosystems where crops can grow year-round, feeding entire colonies. The challenge now is scaling it all up. These farms aren't just for astronauts anymore, they're central to human survival in space. But here's where it gets even more interesting. Space farming is not just about growing food. It's about creating an entirely new ecosystem. To farm successfully on another planet, everything has to work together. The air, the water, the plants, and even the people living there. And that means technology has to be incredibly advanced to make this work. The air inside these biodomes has to be just right. too little oxygen, and the crops won't grow, too much, and people could suffocate. It's all about balance. And speaking of balance, did you know that plants can actually help create a livable atmosphere in space? That's right. Plants take in carbon dioxide and release oxygen, a critical part of what makes long-term space living possible. But don't get too excited. It's not as simple as just growing some plants and calling it a day. The atmosphere inside these farms has to be tightly controlled, and it's a constant juggling act. Everything, from the air pressure to the lighting to the humidity, has to be monitored 24/7. If even one thing goes wrong, the entire farm could fail. So how do we do it? Well, we use technology to simulate Earth's natural systems. One of the big innovations is the use of artificial light. On Mars, for example, the sunlight is weak, and on the Moon, it's inconsistent. To overcome this, space farms use special LED lights designed to mimic Earth's sunlight and provide plants with the right kind of energy they need to grow. These lights can even change depending on the plant's growth cycle. Pretty cool, right? But it's not just about the lighting. Water is another big issue. We don't have oceans or rivers to draw from on the Moon or Mars, so every drop of water has to be carefully recycled and reused. In fact, the systems inside these farms are built to be incredibly efficient, so efficient, in fact, that the water you use to grow crops might end up being the same water you drink. So yeah, you could be drinking the water you use to grow your lunch. It's all part of a closed-loop system where nothing goes to waste. Now let's talk about the crops themselves. Over time, farmers have gotten creative with what they're growing in space. Early on, it was all about leafy greens, herbs, and small fruits. Easy-to-grow crops that don't require a lot of space or time. But the long-term goal has always been to grow a diverse range of food that could sustain entire communities. We're talking grains, potatoes, beans, everything you'd need to build a balanced diet. And, as technology improves, we're getting closer to the day when space farms could produce almost all the food we need to survive off Earth. Okay, so we've learned that space farming is possible, and we've seen how the technology has evolved over time. But let's zoom in for a moment and talk about the people who make it all happen. These aren't your average farmers, folks. We're talking about astronauts, scientists, engineers, and even a few ex-agribusiness experts who traded in their tractors for spacesuits. So, who are these cosmic farmers? What does a day in the life of a space farmer really look like? Let's start with the basics. Imagine waking up not in a cozy bed but in a small, cramped habitat on Mars, or inside a massive biodome on the Moon. No morning coffee shop run, no leisurely breakfast with the family. Instead, you're checking on your crops. You've got lettuce growing in one part of the farm, tomatoes in another, and a few experimental wheat plants in a different section. Everything is tightly controlled, with a constant stream of data showing you how the plants are doing. It's a mix of tech and agriculture that requires constant attention. And here's the thing. Space farming is intense. These aren't small greenhouses. These are full-scale farms that produce the majority of the food for a colony. The responsibility on these farmers is enormous because if something goes wrong, it's not just about losing a crop, it's about feeding an entire colony. It's high stakes. And every day, these farmers are constantly problem-solving. Maybe the humidity in one section of the farm is too high, or the plants are growing a little slower than expected. No matter what, the job requires quick thinking and a lot of patience. So, who exactly are these people? For starters, space farming isn't just about having green thumbs. A lot of these farmers are highly trained scientists and engineers who have been working with cutting-edge technology to grow food in the harshest environments possible. But it's not just about the science, it's about adaptability. Space farming requires people who can think on their feet, who are willing to experiment, and most importantly, who can handle the isolation. Take Dr. Elena Ramirez, for example. She's a plant biologist who's been working on Mars for almost 5 years. When she was first selected for the mission, she was thrilled, but also nervous. After all, it's not like she could run out to a local store to grab some more seeds if something went wrong. You've got to be resourceful, she says. If a crop fails, you don't just give up. You fix it, You find out why it's failing and find a solution. And that kind of mindset is crucial because in space farming, every failure is a learning experience. Then there's Liam Patel, an engineer who specializes in environmental control systems. He's not a farmer in the traditional sense, but he's responsible for keeping everything in the farm environment running smoothly. That means maintaining the atmosphere inside the biodome, making sure the nutrient systems for the crops are functioning properly, and checking the sensors that monitor everything from oxygen levels to plant growth rates. His job is kind of like being the unsung hero behind the scenes. Without him, the farm wouldn't have the right conditions to grow food in the first place. But space farming is not just about individual effort. It's a team thing. Imagine a group of astronauts, scientists, and engineers working together in close quarters, day in and day out, with limited resources and a huge task ahead of them. The teamwork here is unlike anything on Earth. These cosmic farmers rely on each other, whether it's to solve a problem with the crops or just keep morale up during the long, lonely days. And believe me, isolation is a huge challenge. The farther out you are, the more cut off you become from Earth. There are no quick calls to family or friends. You can't pop over to your neighbor's house for a chat. It's just you, your team, and the vast expanse of space. Let's take a moment to think about that isolation. Imagine being thousands of miles away from Earth, surrounded by a barren landscape, and knowing that your food, your entire livelihood, is in your hands. There's no backup plan, no quick escape if something goes wrong. That's the reality for these farmers, and yet, they persevere. They've got a job to do, and they do it well. You'll often hear them say things like, "We don't have the luxury of failure," and they mean it. Now, let's talk about some of the ways these space farmers handle their day-to-day responsibilities. For one, they have to be incredibly organized. Everything from seed storage to water recycling is meticulously planned. If you think about the complexity of keeping a farm alive in space, it's a whole different level. In addition to the biological side of farming, there's the tech side. The equipment that monitors plant growth and the systems that keep everything functioning smoothly require constant maintenance. One broken sensor or malfunctioning water pipe could be catastrophic. But it's not all hard work and no play. Despite the tough conditions, space farmers have found ways to make their lives more enjoyable. One of the favorite pastimes on Mars, for example, is the weekly crop harvest party. Now, it might not sound like much, but it's an event where the team gets together to harvest whatever crops they've been growing that week. Whether it's lettuce, herbs, or even strawberries. It's a chance to relax, share a meal together, and, most importantly, celebrate their accomplishments. After all, growing food in space isn't easy, and every harvest is a victory. But there are also moments of real tension. Sometimes the crops don't grow as expected, or there's a malfunction in the system that could threaten the entire harvest. That's when you see the real character of the space farmers. They know that failure isn't an option, but they also know that with every setback comes an opportunity to learn, to improve, and to push forward. And it's not just about growing food anymore. As space farming evolves, these farmers are now experimenting with new ways of improving crop yields, adding more variety to their meals, and even testing how humans can live off a completely self-sustaining ecosystem. The future of space farming isn't just about survival, it's about thriving. So let's take a moment and think about these farmers, living in space, away from family, friends, and the comforts of Earth, and yet, they're the backbone of humanity's expansion beyond this planet. Every day, they're writing the history of human agriculture in space. Now that we've met the incredible people who make space farming happen, let's dive into the heart of it, the space farms themselves. Picture this: massive greenhouses or biodomes. But not just any kind of greenhouse. These farms are on the surface of Mars or within giant domes on the Moon, carefully engineered to support life where nothing grows naturally. It's not like we just packed up some seeds and hoped for the best. These farms are high-tech, complex systems designed to mimic Earth's ecosystems in a way that can sustain both crops and humans in the most extreme environments. First, let's talk about location. Space farms aren't just hanging out in open space, exposed to the harsh radiation of the sun or the freezing temperatures of Mars. These farms are protected in domes, bunkers, or underground structures to shield them from the elements. The idea is to recreate an environment that's as close to Earth as possible, but with some serious space-age upgrades. Inside these biodomes, the temperature is carefully regulated. There's artificial sunlight, water recycling, and air filtration systems that keep the atmosphere breathable. Imagine walking into one of these farms. The air smells fresh, almost like the earthiness you'd expect from a garden on Earth. But it's also engineered to be perfect for plant growth. The lights above are a bit brighter than you might expect. That's because the sun on Mars is only about half as intense as it is on Earth. The lights are actually high-tech LEDs that simulate the natural spectrum of sunlight. In fact, these lights are constantly changing, adjusting to the needs of the plants below, based on their growth stages. So one moment you might have bright blue light for leafy greens, and then, when you need it, the light turns more red, perfect for fruiting plants like tomatoes and peppers. These lights are a big part of why space farms are so successful at growing a variety of crops, even in places where natural sunlight is limited. But it's not just about the light. Water too is a huge deal. On Mars or the Moon, water is scarce. There's no rivers to tap into, no oceans to desalinate, so the water has to come from somewhere else. And in these space farms, water is treated like gold. Every drop is precious and recycled over and over again. Watering the crops, that water gets filtered and reused. The condensation from the air, the moisture released by the plants, even sweat from the astronauts working inside the dome, it's all collected, cleaned, and put back into the system. These farms are designed to waste as little as possible. If you spill water, it gets caught in the drainage system and goes right back into the cycle. It's all part of making the system self-sustaining, because one thing is clear: you can't afford to waste anything when you're farming on another planet. And then, there's the soil, or rather, the lack of it. On Earth, soil is where most of our crops grow. It's full of nutrients, minerals, and microorganisms that plants need to thrive. But out in space, there's no natural soil to speak of. So, what do? We've created synthetic soil substitutes. These can be made from a mix of volcanic rock dust, recycled plant matter, and other compounds that mimic the nutrient content of Earth's soil. These artificial soils are carefully crafted to give the plants the minerals and structure they need, but they're also lightweight and easy to transport, which is crucial when you're sending everything from Earth to a distant planet. The idea is simple. We're taking what we know about Earth's ecosystems and translating that into a whole new environment. And in many ways, these space farms are even better than Earth farms. For example, in these closed ecosystems, there are no pests to worry about. You won't find any hungry bugs nibbling on your lettuce. There are no seasons, no freezing temperatures that ruin your crops, and no unexpected storms that can wipe out a harvest. The constant, controlled environment means the farmers have a much higher degree of predictability and reliability when it comes to growing food. But here's the catch. Just because the environment inside the biodome is controlled doesn't mean it's easy. It's one thing to create the perfect conditions for crops to grow, but you also have to consider the long-term effects of growing food in a completely closed system. For instance, how do you deal with the buildup of carbon dioxide? Plants absorb CO2 and release oxygen, but the air inside a biodome can get pretty thick with CO2 if not carefully managed. That's where technology comes in again. These space farms use sophisticated air scrubbers to balance the carbon dioxide levels and maintain a breathable atmosphere for both plants and people. Now you might be wondering, how do we make sure everything's growing in the right conditions? Well, space farming relies heavily on sensors. There are sensors everywhere, measuring temperature, humidity, light levels, carbon dioxide, and even the health of the plants themselves. These sensors feed data into a central system which constantly adjusts the conditions based on real-time feedback. It's all about creating a perfect environment for the crops, and the technology makes sure that happens 24/7. It's like having a team of digital assistants watching over every plant. And don't forget about the crops themselves. Space farmers have to choose plants that can grow in these specialized conditions. At first, the focus was on fast-growing, high-yield crops that don't require too much space, things like lettuce, kale, and herbs. But over time, the goal has shifted toward growing a much wider variety, offering new ways to maximize the productivity of space farms. These farms are not just cool experiments. They're practical too. They're the backbone of human life in space. The better we get at farming off Earth, the more self-sufficient we become. And if we can make space farming work on Mars, who's to say we couldn't farm on other planets or even moons one day? The possibilities are endless, so, as we've seen, space farming is pretty incredible. But let's not sugarcoat it, it's not all smooth sailing. Sure, the technology is advancing and the potential is huge, but the challenges are just as big. Growing food in space comes with a whole new set of problems that we never even had to think about on Earth. Let's talk about some of the biggest hurdles these cosmic farmers face every single day. First up, there's the issue of gravity, or rather the lack of it. We've all seen how plants grow on Earth, right? They have gravity pulling down on them, which helps their roots anchor into the soil and grow strong. But in space, gravity's a different story. Take the International Space Station, ISS, for example, where plants are exposed to microgravity. It's a completely different environment. Without gravity, plants don't grow the way they would on Earth. Their roots don't know which direction to go, and their stems don't quite develop the same way either. Plants rely on gravity to orient themselves. So, scientists had to get creative. One solution has been to use artificial gravity or rotate the growing beds to simulate gravity. This helps the plants develop properly. It's not a perfect solution yet, but it's a start. And as we look toward Mars or the Moon, this problem becomes even more important. We're going to need ways to make sure that crops can grow in environments where gravity isn't as forgiving as it is here on Earth. But it's not just gravity that's a challenge. Another major factor is the radiation in space. You might have heard about how dangerous radiation can be in the vacuum of space. Well, it's true. Space radiation can be harmful to both humans and crops. On Earth, we're protected by our atmosphere and magnetic field, but in space there's nothing to block those harmful rays. And even inside a dome or habitat, that radiation still presents a risk to crops. Scientists are working on solutions to this problem too. Some space farms use shielding to block out radiation, while others are experimenting with genetically modified plants that are more resistant to radiation. But this is still a major hurdle. If we want to grow food on Mars or the Moon for the long term, we'll need to make sure that crops are shielded from radiation and that the food produced is safe to eat. Now let's talk about resources, because that's another huge challenge. Growing food in space requires a lot of resources: water, nutrients, energy, and of course, space. And these resources aren't just available on a shelf for you to grab, they need to be carefully managed and recycled. For instance, water is a critical resource. As we mentioned earlier, there's no easy way to get water on Mars or the Moon, so everything has to be recycled. And it's not just water from crops or rain, it's also the water that astronauts sweat, breathe, or use in daily activities. Every drop needs to be captured and reused, which means the system has to be incredibly efficient. And then there's the challenge of energy. Space farms need a lot of energy to run. You've got the artificial lighting, the climate control systems, the sensors, and all the equipment that keeps everything running smoothly. On Earth, we rely on the grid for electricity, but in space, things are different. Solar power is often the go-to solution for energy, especially on Mars, where there's a lot of sunlight. But the problem with solar power is that the sun isn't always shining. On the Moon, for example, days and nights last about 14 Earth days each. That's a lot of time without sunlight. So, space farms have to rely on batteries or other energy storage solutions to keep everything running during the long nights. Energy storage is another area where technology is still catching up. The batteries we have today are pretty good, but they're not perfect. As we push farther into space, we'll need more advanced systems that can store large amounts of energy for extended periods of time without losing efficiency. And while solar power is great, there are other potential sources of energy like nuclear power that might play a big role in powering space farms in the future. Then of course there's the matter of space. If you've ever been in a small room with a lot of stuff in it, you know how cramped it can feel. Now imagine trying to grow enough food to feed an entire colony in a tiny biodome. That's a real challenge. Space is limited, and crops need space to grow. The solution? Vertical farming. By stacking crops in layers, space farms can maximize their use of available space. But even vertical farms have their limitations. Each layer of plants needs access to light, water, and nutrients. So it's a delicate balance, and it takes careful planning to make sure every plant gets the resources it needs. And speaking of careful planning, one of the biggest challenges is something that many of us take for granted: the psychological toll. Growing food in space isn't just about technology and science, it's also about the people doing the work. Space farmers, especially those on long-term missions to places like Mars, can experience isolation, stress, and burnout. Being so far from Earth, surrounded by nothing but vast, barren landscapes, can take a mental toll. It's not just about growing food for survival, it's about staying sane while doing it. That's where the social and emotional aspects of farming in space come into play. Farmers working on Mars or the Moon need to be mentally prepared for the isolation and the challenges of working in a high-pressure environment. And it's not just about the farm, the entire mission depends on the success of the farm. If the crops fail, so does the mission. So, there's a lot of weight on the shoulders of these space farmers, and keeping morale high is just as important as keeping the crops alive. But what happens when things go wrong? Let's say one of the systems fails, or there's a breakdown in communication between the team members. These are real life-or-death situations. The stakes are incredibly high. And that's why the training for space farmers is so intense. They don't just train to grow crops, they train to survive, to solve problems under pressure, and to keep a cool head when things go south. At the end of the day, space farming is about more than just food production. It's about pushing the boundaries of what we know, testing the limits of human ingenuity, and surviving in one of the most hostile environments imaginable. Sure, there are obstacles, but each challenge is a step toward a future where humans can live and thrive beyond Earth. And that's what makes space farming such a powerful symbol of humanity's ability to adapt, grow, and explore. Now that we've covered the challenges of cosmic farming, let's shift gears and talk about some of the amazing innovations that are helping to overcome these obstacles. Because, let's be real, space farming isn't just about throwing a few plants into a dome and hoping they grow. It's a whole world of cutting-edge technology and creative problem-solving that's pushing the boundaries of what we thought was possible. One of the most exciting innovations in space farming is hydroponics. You've probably heard of hydroponics before. It's a method of growing plants without soil, using water that's enriched with nutrients. In space, hydroponics is a game changer. It solves a lot of the problems we face with traditional farming. For one, it eliminates the need for soil, which, as we've mentioned, is practically non-existent on planets like Mars. Instead, plants get all the nutrients they need directly from the water, which is carefully monitored and recycled. And since there's no soil to worry about, it also reduces the risk of pests and diseases that can damage crops. But hydroponics is just the beginning. A really cool variation of this method is aeroponics. Imagine growing plants with their roots suspended in the air, misted with a nutrient-rich solution. No soil, no waterlogged roots, just pure mist. Sounds like something out of science fiction, right? But in space it's proving to be incredibly efficient. Aeroponics uses even less water than hydroponics, which, as we know, is a critical resource in space. Plus, because the plants are suspended, they have access to more oxygen, which can help them grow faster and healthier. It's a perfect system for space farming, where every drop of water counts. Now here's where things get really cool. Vertical farming, I mentioned it earlier, but it's worth diving into a bit more. Vertical farming is a way to maximize space by growing crops in stacked layers. In space, real estate is limited, so we need to use every inch we have. Vertical farming allows us to grow crops on multiple levels, which means we can produce a lot more food in a much smaller area. Imagine a skyscraper filled with plants, each floor dedicated to a different crop. It's a great way to get the most out of the limited space inside a biodome or greenhouse. Plus, vertical farming allows for more precise control over environmental conditions, like light, temperature, and humidity, which makes it easier to optimize growth. And if you think that's cool, wait till you hear about the use of genetically modified crops in space farming. Scientists are working on creating plants that are specifically designed to thrive in space environments. These genetically modified crops are resistant to space radiation. They're more efficient at using water, and they can adapt to the unique conditions of growing on another planet. In fact, some plants have been engineered to grow faster, produce more yield, and even be more nutritious, which is crucial for long-term space missions. Imagine eating a tomato that's been genetically tweaked to give you all the vitamins and nutrients you need to stay healthy in space. It's not science fiction, it's happening right now. But the innovations don't stop there. Another groundbreaking technology being developed is the use of three-dimensional printing for farming. Yes, three-dimensional printing. This might sound a little wild, but it's a real possibility. The idea is that we could use three-dimensional printers to create custom-made plant pots, soil substitutes, and even the necessary equipment for farming in space. And get this, some scientists are even exploring the possibility of three-dimensional printing actual food. Imagine printing a steak or a vegetable from scratch, based on a digital blueprint right there on the space station or on Mars. It might sound far-fetched, but the technology is evolving quickly, and it could be a game-changer for space agriculture. Then there's the idea of using local resources on other planets to help with farming. This is something scientists call in situ resource utilization, ISRU. Essentially, it's about finding ways to use the materials already available on a planet or moon to grow food, rather than relying entirely on supplies sent from Earth. For example, on Mars, there's a lot of regolith, basically dust and dirt, that could be processed to create a nutrient-rich soil substitute. By combining regolith with water and other materials, we could create an environment where plants can actually take root and grow, without having to rely on Earth-based supplies. That's a huge step forward in making space farming truly sustainable. But there's one more innovation that's really worth mentioning, and that's the development of autonomous farming systems. In space, where crew members are already juggling a million tasks and the demands of survival are constantly at the forefront, it's not always feasible for humans to be on site, tending crops 24/7. That's where robotics and artificial intelligence, AI, come in. Scientists are designing automated farming systems that can take care of the plants, without the need for constant human intervention. These robots are equipped with sensors, cameras, and AI software that allow them to monitor plant health, water levels, and environmental conditions. They can even harvest crops when they're ready. This kind of automation not only reduces the workload for the human crew, but it also ensures that everything is taken care of precisely and efficiently. Imagine this. A robotic arm carefully picks ripe strawberries from the vine, another one checks the nutrient levels in the water, and yet another adjusts the artificial sunlight to optimize growth. These autonomous systems could allow space farms to run more smoothly, with less human input, and ultimately make farming in space a lot more feasible for long-term missions. Plus, with AI constantly analyzing the data from the farms, we can expect to see quicker improvements and more efficient farming methods. And it's not just the farming equipment that's evolving. The entire approach to space farming is changing. Instead of just focusing on growing food for survival, scientists are now thinking about creating food systems that can improve astronauts' quality of life. Imagine having fresh, delicious meals that taste just like Earth-grown food, even if you're millions of miles away from home. It's not just about surviving, it's about thriving. And that's a big shift in how we think about farming in space. The combination of all these innovations, hydroponics, aeroponics, genetic modifications, 3D printing, in situ resource utilization, and autonomous farming, are not just changing the game for space farming, but they're paving the way for humanity to eventually live and thrive in space. These technologies are getting us one step closer to the dream of becoming a multiplanetary species. Alright, now that we've covered the technology and the challenges, let's talk about the big picture. Where does all this lead? What's the long-term vision for space farming? Well, as amazing as it is to grow food on the moon or Mars, it's not just about feeding a small group of astronauts. No, the ultimate goal is much bigger. We're talking about creating sustainable, self-sufficient colonies that can survive and thrive on other planets. And farming is at the heart of that vision. Take Mars, for example. If we're going to establish a colony there, we need to be able to produce everything locally. That means we need to grow not only the basics like vegetables and grains, but also more complex foods, like fruits, meat alternatives, and even dairy. In order to make that happen, we're going to need a variety of farming systems: vertical farms, hydroponics, aeroponics, even livestock farming, if we can figure out how to raise animals in space. But farming on Mars doesn't just stop at food production. In a fully sustainable colony, farming would play a huge role in recycling vital resources. We'd be using plants not just to eat, but also to help purify the air and water. For example, plants can absorb carbon dioxide and release oxygen, which means they could help maintain breathable air in a Mars habitat. In fact, plants could play a crucial role in regulating the atmosphere inside biodomes, helping to stabilize the environment for human inhabitants. The same principle applies to water. Growing plants in space doesn't just give us food, it also helps with the water cycle. Water used in farming can be recycled, purified, and put back into the system, which creates a closed-loop ecosystem. If we can perfect this system, it'll mean that future colonies can be far less dependent on Earth for supplies. Everything from water to air to food will be sourced locally, and the need for Earth-based shipments will diminish. The more we rely on resources available on Mars, the more sustainable the colony becomes. But let's think even bigger. What if we could take space farming and adapt it to other parts of the solar system? What if we're not just farming on Mars, but also on the Moon, or even on moons like Europa or Titan? The future of space farming isn't limited to just one planet. As our technology advances, we'll be able to develop farming systems that are adaptable to a variety of environments. Whether it's the harsh surface of the Moon, the frozen landscape of Europa, or the methane-rich atmosphere of Titan, each of these places presents unique challenges but also incredible opportunities. For example, let's talk about Titan for a second. Titan, one of Saturn's moons, is one of the most fascinating places in the solar system. Its atmosphere is mostly nitrogen, and it has lakes of liquid methane. While this might sound completely inhospitable to life as we know it, Titan has its own kind of chemistry that could be harnessed in creative ways. We might not be growing wheat on Titan anytime soon, but there are other possibilities. For instance, we could use its resources to create bioreactors or even methane-based plants that could sustain a future colony there. It's mind-blowing to think about how space farming could one day work in such an alien environment. And what about the Moon? Well, the Moon might actually be one of the most promising places to set up a farming colony first. It's close to Earth, it has sunlight for half of each day, and its gravity is lower than Earth's, which means farming there could be a little easier than on Mars. We've already seen some experiments with growing crops in lunar soil simulants, and researchers are optimistic that we could eventually use the Moon's resources for farming, including extracting water from ice deposits in permanently shadowed craters. In fact, NASA is already laying the groundwork for sustainable lunar exploration through their Artemis program, which includes plans for a permanent base on the Moon. But let's take it even further. Imagine a future where space farming extends beyond the planets. Picture this: huge self-sustaining space stations orbiting moons or even other planets, with massive biodomes growing food for millions of people. These space stations wouldn't just be research outposts, they'd be bustling, thriving communities with their own farms, ecosystems, and economies. These habitats could serve as launching points for further space exploration, and they could provide a stepping stone for humanity to expand beyond our solar system. It sounds like science fiction, but it's not as far off as you might think. In fact, there are already plans to create space habitats that could support human life for extended periods of time. The International Space Station, ISS, has been a proving ground for many of these technologies, and we've learned a ton about what works and what doesn't when it comes to growing food in space. The next step is to take those lessons and scale them up, moving beyond small experiments to full-fledged farms that could feed entire colonies. And while we're on the subject of scaling up, let's talk about the role of artificial intelligence in this future. As we move towards more advanced space farming systems, AI will become absolutely essential. AI can optimize everything from plant growth to resource management. Imagine a system where AI not only monitors the health of the plants, but also anticipates potential issues, adjusts the lighting and water systems automatically, and even plans crop rotations to ensure maximum productivity. With AI running the show, human farmers can focus on higher-level tasks, while the technology takes care of the day-to-day operations. The potential is endless. With advancements in farming techniques, technology, and artificial intelligence, we're looking at a future where space farming doesn't just sustain small crews on Mars, it could support entire civilizations across the solar system. And the best part? These innovations don't just benefit space colonies. Many of the technologies we're developing to farm in space could have real-world applications here on Earth, helping us solve issues like food scarcity, resource management, and climate change. We've spent a lot of time talking about space farming, but here's something really exciting to think about: the impact that all these innovations could have right here on Earth. You might be wondering, what does farming on Mars or the Moon have to do with us down here on Earth? Well, it turns out, the technologies being developed for space farming could help solve a lot of the problems we're facing with food production, resource scarcity, and climate change right now. Let's dive into how space farming could make a huge difference for us here at home. First, let's talk about food production. With the global population growing, feeding everyone in the coming decades is going to be a major challenge. Traditional farming is facing pressure from things like climate change, shrinking land, and water scarcity. But some of the technologies being tested for space farming, like hydroponics and aeroponics, could revolutionize the way we grow food on Earth. These soil-less farming methods use much less water and land compared to traditional farming, making them perfect for areas that struggle with droughts or have limited arable land. In fact, hydroponics and aeroponics are already being used in urban farming projects, where space is limited but demand for fresh food is high. Imagine growing crops in a vertical farm in the middle of a city, using minimal water and energy, and without needing huge expanses of land. This kind of farming could help cities become more self-sufficient and reduce the carbon footprint of transporting food long distances. And with space farming technologies advancing, the systems we develop for Mars could eventually be used right here on Earth to make food production more sustainable. But it's not just about growing food differently, it's also about growing it more efficiently. Space farming has shown us that by using precise, data-driven systems, we can optimize how plants grow. Things like artificial intelligence, sensors, and automation are already being used on space farms to monitor everything from soil conditions to nutrient levels. This kind of technology could make farming on Earth far more efficient, reducing waste and ensuring crops get exactly what they need. This could be a game changer, especially in regions where food security is a constant struggle. Another area where space farming could help Earth is in resource management. As we mentioned earlier, water is one of the biggest challenges in space farming. Everything has to be carefully managed and recycled. Well, the same goes for Earth. Water scarcity is becoming an increasingly urgent issue in many parts of the world. But the water recycling techniques being developed for space farming, where every drop of water is captured, filtered, and reused, could help us tackle water scarcity on Earth too. We could use similar systems to reduce water waste and make sure that every drop counts, especially in drought-prone areas. On top of that, space farming systems are designed to create closed-loop ecosystems. That means the waste from one system is used to support another. For example, the oxygen produced by plants can be used to keep the air breathable, and the carbon dioxide exhaled by astronauts can be absorbed by the plants. On Earth, we could adapt these systems to create more sustainable farming practices. By using natural waste from livestock or crops, we could help reduce pollution and make farming more eco-friendly. But the benefits of space farming don't stop at food and water management. One of the most exciting areas of innovation is how we might tackle climate change with space farming technologies. We already know that plants play a crucial role in absorbing carbon dioxide and releasing oxygen. In space, where every system is closed off and self-sustaining, plants are even more important for maintaining a livable environment. By applying this same principle here on Earth, we could develop urban farming systems that help offset the carbon footprint of cities. If we can scale up space farming methods to work in our cities, we could not only produce more food locally, but we could also create green spaces that help absorb CO2 and provide cleaner air. And it's not just about climate change, it's also about reducing food waste. On Earth, we throw away an incredible amount of food every year, up to 1.3 billion tons of food globally. A lot of that waste comes from inefficient farming practices and transportation issues. By improving farming technology, space farming could help reduce food waste by making the entire process more efficient. For instance, precision farming techniques, where sensors and AI help determine exactly when to water, fertilize, or harvest, could drastically cut down on waste. We could grow more food with fewer resources and less waste, which could help address global hunger and food insecurity. Another impact space farming could have on Earth is in the way we think about food production. Space farming forces us to reconsider our entire approach to agriculture. It's about finding new ways to grow food in the most efficient and sustainable way possible, which could inspire a new generation of farmers, scientists, and innovators to rethink how we approach food production here on Earth. It's not just about growing crops in space, it's about changing the entire mindset around food sustainability, resource management, and innovation. So, while space farming might seem like a far-off dream, it's actually shaping the future of agriculture on Earth in ways we're just beginning to understand. The innovations happening in space are pushing us to rethink what's possible when it comes to feeding the planet. Whether it's through more efficient farming methods, better resource management, or new ways of dealing with climate change, the lessons we're learning from space farming could have a profound impact on how we feed the world in the years to come. In many ways, space farming isn't just about getting crops to grow on Mars or the Moon. It's about finding the solutions that could help us all thrive on Earth too. As we push the boundaries of space exploration, we're also unlocking the future of agriculture, not just for astronauts but for everyone on this planet.